there. When do we use our different measures of effect? Well, if we have a cross-sectional study, we will get perhaps the odds ratios and the prevalence ratios from that particular study. We will be able to use those in our estimation of size of the effect sizes that we see, and we will be able to get a test of that against the null hypothesis of the odds ratio or the prevalence ratio is equal to 1. In a case control study, we will only get the odds ratio. We won't be able to ratio because the case control study does not estimate the prevalence, because the cases and the controls have been chosen with a different frequency. The cohort study, we will usually get the rate ratio. The reason why the risk ratio is here is that some people call the rate ratio the risk ratio. I think the risk ratio is a little bit ambiguous in what it means. I think that risk ratio is often used as a term for any type of ratio that we have. But rate ratio is proper cohort study where we're comparing the rates in one group with the rates in the second group. Okay. So how are these measures related? Well, if the disease is rare and we have appropriately designed studies, then the odds ratios and the risk ratio are going to be approximately similar. The odds ratio and the rate ratio are most often used in epidemiology because that is the mathematical means by which we have which have been programmed into our statistical calculations. The logistic regression and the Poisson regression that we have for rate ratios are going to be the most useful and easy to use in epidemiological studies. Okay, so I think effect measures are going to be something which we will use when we compare different groups, and we can do that whether we're using primary data that we've collected ourselves or whether we're using secondary data that we've obtained from elsewhere. Just as a quick task number 3 before I finish, this is a 2x2 table. Can we calculate the risk difference from this? Can we calculate the risk ratio and the odds ratio from this? Yes, we can. The statistical test shows that the chi-squared for this particular 2x2 table has a value of 29 and a p-value less than 0.001. How would you interpret this finding? And then the second question here, if you wanted to develop a study to explore the effect of drought on anxiety, what population would you use for this study? And what study design would you use? And how would you measure the anxiety that might be present in this population? So that's how I'm going to finish. Any questions we can ask for some questions, or any hands up, I can have a look and see whether we can get some comments from different people. Just looking at the comments in the chat. Most of them are about the attendance log and the link to that. So I'm not going to answer those. I'll let Diana answer those.
Hello, Doctor.
Any comments on this?
Hello?
On this question? Calculate the
Can you
risk
hear me?
difference, the risk ratio. Yes, who's that?
Abdul Karim.
Dr. Abdul Karim. Yes, that's right. Go ahead.
You are highlighted for the last session in this presentation.
Sorry?
If,
Yeah.
you are highlighted in this session, especially for the last session, if the disease it is rare, most probably the odds ratio and risk ratio and rate ratio are the similar.
Yes. Yes.
How
They're not
possible?
they're not going to be exactly the same, but they could be similar. Yes. Go ahead.
What I mean, there is a evidence-based studies available for this issue. If yes,
Well,
you can share.
yes. Go ahead. Go ahead. Yes.
If yes, we need to share this information. This is new
Yes.
for me. I need to learn more about. If the disease is rare, mostly you says it's a similar odds ratio, risk ratio, and rate ratio. It is mostly
Yeah.
probably a similar.
Yeah. So if the odds ratio is, if the disease is rare, that means, let's say the prevalence is less than 1%, in which case, it's going to be the prevalence ratio, the prevalence in each of our groups is going to be divided by the total number at risk. Okay. And if it's less than 1%, those are going to be, 1% in each case, let's say, or something like that. Where if we're calculating the odds ratio, we're going to be dividing by the number who haven't got the disease. And although that's not going to be exactly the same as the number who in total, it's going to be very similar to that. It's going to be dividing by 99 rather than 100. And so the estimates of our odds and our odds ratios are going to be very similar to the evidence to the estimates of our prevalence and our prevalence ratios. So that's just due to the fact that we're looking at something which is very rare, less than 1%. And similarly with the rate ratios, they are also going to be very similar to the prevalence ratios and the odds ratios. Yes. So I'd have to look it up in a book and get you the evidence, but I'm sure it's in something like Heineken's or something like Woodward and Co. But the evidence is there for the rare diseases, the odds ratio, the risk ratio, and the rate ratio all going to be similar. Okay, Dr. Yinka first, and then we'll have Riri.
Can I ask another question?
Okay, yes, Abdi Karim, yes.
Yeah,
hang on 1 minute.
For the standard error, you are telling us they are using mostly for the testing hypothesis and creating confidence interval.
Yes.
During the development confidence interval, mostly we use 95%, 99%, and 90%. Why we use 95%? In our setup, mostly we encourage as we are medical, it is better to use 99% rather than 95%. Any update for that, for the difference confidence interval for 90%,
so,
95? Why we use 5 rather than 91%?
Yes, so 95% confidence intervals and the 5% significance was, I think, is something of a legacy from the Fisher, who first developed these tests back about 100 years ago. And he thought this was a very convenient sort of like number because it was close to 2. And so he said that a confidence interval where you multiplied the standard error by 2 would give you something which is quite intuitively interesting. And 5% he thought was sufficiently small to be useful for most people. They say, yes, we can sort of take a 5% significance. Anything less than 5% is going to be significant, and that. So there's no real reason for it. It's just something which has grown up over time as something convenient. Which I think in epidemiological studies is quite useful. Having a 5% significance and 95% confidence interval seems to fit well with epidemiological studies. Genetics and many other people who want to have a much stricter confidence interval will often take 99.9% intervals because they really do want to be sure that they are restricting, they are looking at something which they can be 99.9% sure that the effect is within that range. And so I think there are groups of people who have taken other confidence intervals and other significance tests, which are different from what you use as epidemiologists. But I think in epidemiological studies, I think the 5% significance and the 95% confidence interval is still the one which is most used by people today. And I'm very happy for other people to use other confidence intervals and significance tests, but I think it's going to be difficult to change epidemiology as it is now, where we use 5% significance and 95% confidence. Okay. Thank you for the question, though.
Thank you, Prof.
Dr. Yinka, you had a question.
Thank you very much, Jim. My question is, how can one calculate odds ratio for cross-sectional study, knowing fully well that it's just one group? Cross-sectional study is just across a sample size, one group.
Yep.
Is a snapshot.
Okay. So we have a 2x2 table right here on the screen at the moment, in which we have 25 have experienced anxiety and have, had a background of drought. And so this might be a cross-sectional study because we measure the anxiety in these 500 people, and we find that 50 people had anxiety, so 10% anxiety in this population. And we also asked them a question about, did you experience drought in the last year? And of those, 100 or 20% had experienced, got that wrong way. 100 people had experienced anxiety, isn't it? Which is 20%. And 50 people had experienced drought in the last year. So we were looking in one particular district, perhaps, and for 50 people, they had experienced drought, and perhaps they had crop failure, and perhaps that added to their anxiety. So 100 people had experienced anxiety, and 50 people had experienced drought here. So it's so 50 people here and 100 people here. So we can estimate the odds of anxiety amongst people who experienced drought, and the odds of anxiety amongst people who experienced drought. That was taken this column here, and here we have 25 people here who have experienced anxiety and drought, and 25 people who have not. So the odds there is going to be 25 divided by 25, which is 1. Okay. And so we'd say that the odds of anxiety amongst this group here is going to be 1. The odds of people who experience anxiety amongst those who didn't experience drought is going to be 75 divided by 375, which I'd have to do the calculations. 75 divided by 375 is going to give about 0.2. Okay, so the odds in this group here who have experienced drought is 1. The odds in those who've not experienced drought is 0.2. So the odds ratio is going to be the odds in those who are exposed, experienced drought, divided by the odds of those who are not exposed. 1 divided by 0.2 will give us an odds ratio of 5. So we just divide the odds of those who are exposed divided by the odds of those who are not exposed. Does that answer your question, Dr. Yinka?
Yes, it does. But I'm just looking at this table that maybe it's a case control study.
It could be a case control study. It could be a cross-sectional study. And the output in the table will be similar for both.
Okay. Thank you very much.
Okay. Okay. Question from Riri. Do you ask your question?
Yes, Professor, thanks so much for taking us through this session. It has been very informative. However, I have one thing that I just wanted to clarify. Any session of this nature is an opportunity to always learn new things. So we had a section on calculating sample size. I would like just to get some clarification on calculating a situation where we can have two population proportion formula. In which situation can we be able to use two population proportion formula?
Mhm.
Thank you.
So you want the formula for sample
Two-
size, is that right?
Yes, formula for
Okay.
yeah. I just wanted to find out in which situation or in which condition can one be able to use two population proportion formula.
Okay, so if you're comparing two populations or two groups
Yes.
within a population, then you
Mm.
should be able to use that two population formula. Yes, and
Okay.
of course, the sample size you can use. You've got different sample size calculations if you're going to be using an outcome which is a continuous outcome, such as a mental health score, or
Yes.
if we're using a proportion or prevalence, then you have a different sample size calculator. And if you're using a rate, then you'd also have a different calculator. But each of them, use a very similar kind of two population calculation. And you can use that if you have two populations within the same two populations which you're comparing, which are different from each other, or two populations or two groups within the same population.
Okay. Okay. Thank you.
Okay. Good.
Thank you.
Okay. James, I'm going to give you a chance to unmute and talk and ask your question. James and Dimby. Okay. James, you've got a question.
Yeah, sorry,
Yeah. Oh, sorry. Was that a mistake then? Yes. Okay. No problem. No problem. Okay. It says, how did you get the chi-squared value of 29? I'm getting a value of 31. Okay, so in this 2 by 2 table that we've got here, I had a chi-squared of 29, but Atim gets 31.25, which is fine. I think the difficulty, the thing is there are slightly different ways of calculating chi-squareds. And a value of 29 is very large. A value of 31.25 is also very large. I think the point is we shouldn't get too worried about whether we get small differences in our values there. Both of these are going to be highly significant because the value of 29 on a chi-squared from a chi-squared distribution with 1 degree of freedom is going to be a very, very small. It's going to be less than 0.05. So we're going to have a significant test here. We're going to have a significant difference in the anxiety between those who experienced drought to those who didn't experience drought, because the chi-squared value here is way bigger than you would expect from the 5% significance on 1 degree of freedom. And so we should interpret this finding as saying we can reject the null hypothesis that anxiety is the same in people who experience drought and people who don't experience drought. And we can say that, yes, there is greater anxiety amongst people who experience drought than people who don't experience drought. And if we calculate the odds ratio as we did there, the odds ratio would be 5. For people who have experienced drought, they would have a 5 times higher odds ratio or odds of anxiety than people who didn't experience drought. Okay. If you wanted to develop a study to explore this effect, then you would have to use the population of the district, which is to drought, at least subject to drought, and some of it is not. And you would then be able to do a cross-sectional study on this, but you could also use a case control study, as someone mentioned earlier in the conversations. This could come from a case control study as well, whereby we're looking at people who come into the hospital with signs and symptoms of anxiety, and we ask them some questions about whether or not they've experienced drought in the past year or 2 years. Yeah. How would you measure the anxiety? Well, we could use a screening tool for that, or we could use a more precise clinical estimation of the effects of to measure anxiety. I'm not a clinician, so I wouldn't be able to say exactly what that clinical examination would be, but I'm sure that there are some people here who could provide that. Okay, any final questions here? As Joel says, materials on this course will be provided using the website that you have there, the Mental Health Database Africa.aphrc.org. And then we can also, there's also on YouTube. Dr. Inka says, when should one use less than 0.001? I think if you're a geneticist, I've got a need for a very strict significance test of 0.001, then you can do that. I think most epidemiologists would say, even if they get a p-value there of less than 0.001, they would say that's significant because it's less than the 5% that we usually use for our significance tests. Okay. So I'm not saying that we have to use 0.001. We should accept the fact that this is going to be significantly different. Anxiety is significantly different between those who experience drought and those who haven't. Odds ratios have a range. An odds ratio is got to be positive because it's got to be greater. The odds ratio of 1 is the null hypothesis. Odds ratios of less than 1 represent some kind of smaller odds of the outcome in the exposed compared to the unexposed. Odds ratios greater than 1 represent larger odds of the outcome in those who are exposed compared to those who are unexposed. All of the odds ratios are positive. You can't have a negative odds ratio. Odds ratios which are close to infinity or close to 0 are almost complete in terms of the association between the exposure and the outcome. An odds ratio of 20 makes sense. It just means that there's 20 times higher odds in the exposed group compared to the unexposed group, which means that it's a very high effect size, very large effect size, and you wouldn't need a large study size to ascertain that odds ratio. Yeah. I think we've reached the conclusion. It's about 4:30 my time, probably different times in different parts of Africa. I say thank you very much for attending. If there's any questions or further comments, I'm happy to answer them through the team in the Mental Health Data Prize, which I shall be part of, which I am part of, and look forward to further discussions and things as we go on. Any final questions there? Any final hands up? Otherwise, I shall say thank you very much. And we shall. When's the next one? Joel, Diana, when's the next training session?
The next training session should be on the 23rd, but we shall share the invitation calendar on
Okay.
Yeah, once everything.
So that's next Friday, is it? Yeah.
Yes, that's next Friday.
Okay.
Yeah.
Thank you very much.
Okay, thank you. Thank you so
Okay.
much, Professor. It was quite an interactive session. I'm sure so many people have learned a lot and they're very glad. I can see through the reaction. Yeah.
Yeah. And thank you. Thank you for all the comments, because I really do like to hear what people have got there and how they've their reactions to it. Thank you. Okay, thank you very much.
Thank you for the wonderful presentation. Thank you, Allah.
Okay.